Hi everyone, so today we're going to tackle lesson 27's application problem. So I'm going to go ahead and read it to you and we're going to write it out and work it out together. It says that Jeremy ran 27 laps on a track that was 1/8 mile long. Okay, so think about it. I mean, you guys have all gone to Oval Park and run around that track. Think about Jeremy running around that track 27 times. So he ran around the track 27 times and the track was 1/8 of a mile long. All right, so let's continue to see what it says. It says that Jimmy ran 15 laps, okay, on a track that was 1/4 of a mile long. So he ran 15 laps around a track that was 1/4 of a mile long. Now you might be saying, Ms. Lahosky, why are you automatically doing multiplication? Well, I know that if my track was 1/4 of a mile long and Jimmy ran around it 15 times, that would really be the same as saying repeated addition, 1/4 plus 1/4 plus 1/4 plus 1/4, and so on and so forth until you got to 15 1/4. So as we all know, multiplication is a much faster way to do repeated addition. So that's how I know it's multiplication. Now, the rest of the problem says, who ran farther? So I know right now that we are going to be comparing Jeremy's distance of running against Jimmy's distance of running. So I know from prior lessons that when I multiply a whole number by a unit fraction, I'm really just multiplying the whole number times the numerator, and my denominator stays the same. So my denominator will stay the same for Jeremy, and I'm doing 27 times 1, which we all know because of the identity property of multiplication, any number times 1 is the number itself. So we have Jeremy running 27/8 of a mile over those, the time that he ran. Now let's do the same math for Jimmy. So Jimmy is 15 times 1/4 gets me 15/4. Okay, so now I'm left with comparing. And remember, when we compare boys and girls, we're using the symbols less than, greater than, or equal to. So that's what we're going to try to figure out right now with Jeremy and Jimmy. Now I'm looking at these two fractions and I can tell a couple of things. I can tell that they have different denominators. So Jeremy is, his is divided into 8 and Jimmy's is divided into 4. So it's going to be a little bit more difficult for us to sit here and compare these two numbers and these fractions rather. And let's just say that because the numerator is more than the denominator for both of these, that these are fractions that are greater than 1. So now we need to think for Jeremy. He ran 27/8. Jeremy ran 27/8. And we have our boy Jimmy over here with 15/4. Remember, the goal is to figure out who ran farther. So that means who ran the most. So we're looking to figure out what is bigger, 27/8 or 15/4. Now remember, fourths are bigger than eighths. Remember if we said we were going to share a candy bar, right? Wouldn't you much rather share a candy bar with 4 people versus 8 people? Because I know that the piece of candy that you would get if you share it with 4 people will be much bigger than if you share it with 8 people. So it's hard to compare these two because the whole that it's broken into is not the same. So now I need to think, how can I convert or change my fraction that is more than 1 into a mixed number? A mixed number is a whole number and a fraction, kind of like something like 2.5, right? 2.5 is a mixed number. 2 is the whole number and 1/2 is the fraction. A lot of you guys say like, oh, I'm 9.5 years old. That's actually a mixed number because you have a whole number and a fraction. So we need to think, how many eighths in a whole? Well, we know that when the numerator and the denominator are the same, right? I'm going to actually get rid of that equal sign. We know that that's equal to 1. So now we have 27/8. So we need to think of how many 8/8 we would need to get up to 27. Well, it's very similar to division. We need to think how many 8s go into 27. So 1/8 or 8/8 would be 1. Another 8/8 would be 2. 3 8/8 would be a third. So now if I add these up, I have 8/8, 16/8, 24/8. Now, if I go one more 8/8 up, that's going to be 32 eighths, and I don't have 32. I only have 27. So here I'm up to 24. So I do 27 minus 4, and that leaves me with, this is kind of like my remainder, my remaining eighths that I have left over. So which is this. So now I would count up my holes, 1, 2, 3, and then what I have left over, and I would say that 27 eighths is equal to 1 and 3 eighths. So that's for Jeremy. Now let's look at Jimmy. So now we know that Jimmy's denominator is 4. We know that 4 fourths equals 1 whole. But see, boys and girls, here we have 15 fourths. So we know that this fraction is going to be more than 1 whole. Well, here right now, 4 fourths is 1. Another group of 4 fourths, so that makes it 8 fourths. That's our second whole. Then we get another group of 4 fourths, which is 12 fourths, right? 4, 8, 12 is also a 1. Well, we're at 12 right now, and we have 15. So we can't go up one more group of 1 because that gets us to 16. And we only have 15 fourths to give out. So that's going to leave us with a remainder of 3 fourths. So once I count up all my 4 fourths, which are 1 whole, I can see that I have, this is 3, I'm sorry. Once I see that I count up all my holes, I have 3 holes with 3 fourths left over. And now I need to compare these, right? So I just kind of figured out these fractions that are greater than 1. I figured out what they are in a mixed number. So now I am comparing 3 and 3 eighths versus 3 and 3 fourths. Well, we know that 3 is equal to 3, right? So we don't really have to compare those because 3 is equal to 3. So we're left with 3 fourths and 3 eighths. This is where I would typically draw a model for you guys, but right now I'm going to use my fraction tiles, and we're just going to kind of look at them. Remember that when you're drawing your models, whether you cut the model into eighths or fourths, your models should be the same. What I mean by that is, here would be my models. See how they're pretty much the same. If I cut this one into fourths, and I cut this one into eighths, which would be just cutting into fourth twice, now I need to compare 3 eighths and 3 fourths. So this is 3 eighths. Nope. I'm sorry, this is 3 fourths, and this would be 3 eighths. 1, 2, 3. So, I mean, if you just look at these two, you can see that the 3 fourths is a lot bigger. And what I mean by that is more of the 3 fourths is shaded than the 3 eighths. But if we were going to take our fraction tiles and just kind of line them up just to see, just to make sure we're right. Right? Look at that. We can clearly see that 3 fourths is bigger than 3 eighths. You know, we were talking about cross multiplication, which I don't really like you to do. However, if you want to check your work that way, just to be sure, you can. 4 times 3 is 12, and 8 times 3 is 24. Then we're looking, is 24 bigger than 12? Yes, it is. So Jimmy, since 3 fourths is bigger than 3 eighths, we know that Jimmy ran farther. Thanks, guys.